السلام عليكم أصدقائي الطلاب. Welcome to Chemistry Online with Mr. Ahmed Suleiman. Today we are going to study a new topic which is hydrocarbon compounds. First we will study what's meant by hydrocarbon. We have a branch in chemistry called organic chemistry. Why they call it organic chemistry and what is meant by hydrocarbons? From the name of these compounds, hydrocarbons, it means it has carbon in the presence of hydrogen. It has carbon, and the carbon, you have to remember, that has 4 covalent bonds. You remember, carbon must have 4 covalent bonds, like this, like this, like this, like this, with other atoms, whether hydrogen or something else. Sometimes it has like this double bond with 2 single bonds. The overall are 4, or it has triple bond with single bond like this, or even it has double bond with double bond. Any of these cases means carbon has 4 covalent bonds around it. This branch this field is called organic chemistry because from long ago they found that the compounds came from living organisms, and you cannot form these compounds, so they are organic compounds. For this reason they called it like this and classify it like this. But they found something else. This branch called organic compounds for this reason, and they call this branch organic chemistry. But a scientist called Wohler refuted this idea, or he tried to prove that something else. One of these organic compounds, they thought it came from organisms, urea, but he synthesized it by inorganic substances. This urea is an organic compound found in urine. So they call this branch not organic chemistry but carbon chemistry, and the compounds called carbon compounds because all of them composed of carbon with something else of the atoms. First we will study the first type of compounds, which is called hydrocarbons. From its name, hydrocarbons composed of mainly carbon and hydrogen only. The simplest compounds of organic called hydrocarbons. This is the simplest organic compound because it's composed only of 2 atoms. Hydrocarbon is an organic compound that contain only carbon and hydrogen. The simplest hydrocarbons are compound called methane, which is CH4, and ethane, which is C2H6. And methane is a major component of natural gas, about 94% or more. I told you that before, I guess. You have to remember, again, carbon must have 4 bonds. Why? Because it has 4 valence electrons. You remember that? Carbon has 4 valence electrons, so it needs to make covalent or share with 4 other electrons here to form 4 bonds. The carbon can form methane by linking with 4 hydrogen atoms, which each one has 1 electron, so it can form methane easily by this method. So if I ask you why it has 4 bonds, you can say because it has 4 valence electrons, the carbon. So it forms 4 covalent bonds for this reason. But look, methane is not atypical of the vast majority of organic compounds. Why? Why methane is not like this? Because in this organic chemistry or hydrocarbon especially, the carbon must link with other carbon, at least one or more. One link with another carbon or more. But in the case of methane, methane is CH4, H. So, no bonds between carbon and the other carbon because it's only one carbon. So, methane has no carbon link with other carbon. It has only one carbon, so it's not typical of the vast majority of organic compounds for this reason. Look at this compound, for example. We can say this compound is an organic compound. You know why? Because we have here carbon with other carbon linking together, at least one with the other one. This compound is ethane. Ethane is C2H6. Or we can write it like this, C with C and the H here, 6 H's like this. So it's C2H6. This is H's and those are carbons. So this is ethane and this is hydrocarbon. So if you have a stable carbon bond like this is a reason that make the carbon stable and it can form different compounds. Look at this hydrocarbon, methane and ethane. We can represent the formulas of hydrocarbons by different methods. First, we studied that structural formula, like I represented CH4 by this method to represent the bonds and the atoms, called structural formula. Or if it's ethane, like this, you represent the bonds, all bonds here, and the atoms. Another method called ball and stick model to represent them by balls for some atoms and stick for bonds. If you want to represent it by space filling model like this without stick, like balls only, they are models, but you have to know only to draw structural formula. It's the most important one. Let's see the properties of hydrocarbons. From what I did, you have to know we have electron pair in the carbon-hydrogen or in the carbon-carbon. How? If you have bond between carbon, as I said, it has 4 electrons, and the hydrogen, for example, hydrogen has 1 electron. So what happens here? Bond is forming between a pair of electrons. This is carbon-hydrogen bond. And if it's carbon with other carbon here, other carbon has 4 electrons. So we have here pair of electron to form a covalent bond between carbon and carbon bond. So whether carbon-hydrogen, whether carbon-carbon, electron pair exists here to make sharing. And the sharing here between carbon and hydrogen or between carbon and carbon are almost equally by nuclei of the atoms forming this bond. Yes, it's equal between carbon and carbon, but in carbon and hydrogen almost equal because no big difference between them in their electronegativity as we studied before. So they almost equal in their sharing. For this reason, these kind of compounds, hydrocarbon, are nonpolar. We studied before. So we can say hydrocarbons are nonpolar molecules because the attraction between the electrons in carbon-carbon bond or carbon-hydrogen bond almost equally. And the attraction between them very weak, according to van der Waals attraction force, remember that. For this reason, the hydrocarbons with low molar masses tend to be gases or liquids, and it boils at low temperature. How come? If you have hydrocarbon with one carbon, or two carbons, or three carbons, or four carbons like this, they are in the case of gases. If it has 5 carbons, for example, it's liquid up to 10 or 12 like this. يعني it means the masses are lower here than other compounds that composed of large number of carbons, which is heavy. The low molar masses of this hydrocarbon are, in the case of gases, than liquids, even at room temperature. For this reason, look at this, one of the compounds of organic oil. You remember what general rule we got before? Like dissolves like. What does it mean? It means if you have inorganic compound dissolves other inorganic compound, but if it's organic compound dissolves other organic compounds. Like dissolves like dissolves like. This is the meaning of that. Here we have nonpolar compounds, which is oil. The other compound is water, polar compound. You can dissolve oil in water? No. Why? Because like dissolves like. This is an example. You cannot mix them together, so oil and water don't mix. We have in the hydrocarbons 3 types of compounds: alkanes, alkenes, and alkynes. Today we are going to study alkanes only. What is meant by alkanes? The examples of these alkanes, methane and ethane. Alkane has only single covalent bond between carbon and carbon. So alkanes are hydrocarbons in which there are only single covalent bonds. How can we arrange the carbon atoms in alkane? We have 2 possible arrangement for carbon atoms in alkane. One called straight chain. If you have carbon with carbon in a straight chain like this and so on, or branched chain like carbon with carbon like this, but you have carbon here or like this, carbon here branching like this, chain that has branches. So we have 2 possible arrangement here. The first type is straight chain alkanes. The straight chain alkanes like ethane, we cannot say methane. Methane has only 1 carbon. But in the case of ethane, we have 2 carbon atoms here. Ethane is like this, C2H6, and this is the structure formula. It contains number of carbon atoms, any compound I mean, with hydrogen atoms linking together, and all bonds here are single, and the carbon here in a straight chain, straight, whether 2 or more. Look at propane here, propane C3H8, look, carbon, carbon, carbon. Straight means followed like this, so it's straight chain here. Butane, butane C4H10, 4 carbons, 1, 2, 3, 4, like this. So we can call it straight chain alkane, not branched. Straight chain alkanes, from this graph, we can predict that when the number of carbons increases here, 2, 4, 6, 8, and so on, what happens to the temperature? Boiling point, I mean, increases. Look, boiling point increases. Why? While increasing the number of carbons. So, you have to know the melting and the boiling point. Melting if it's solid, boiling if it's liquid. They vary according to the number of carbon, straight chain alkane. When it increases, the boiling point or melting point increases as well. The straight chain alkane are an example of homologous series. What's meant by homologous series? If you have group of compounds, we can call it, or we can say they form a homologous series if they have an increment of change and it's constant. What does it mean? It means if you have compound like this, CH3, CH2, CH3, it's hydrocarbon. The next hydrocarbon, which is CH3, CH2, CH2, CH3, it's another hydrocarbon. The next hydrocarbon is CH3, CH2, 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 CH3, and the next, and the next, and so on. What happens here? What happens here is we have an increment of change from this to this and from this to this. Every time we have group increases more than the previous one. Look, we have here 1 CH2, here we have 2, 1, it increased by 1, here we have 3, it increased by 1 also. So this group of compounds called homologous series. What does it mean? If the compounds or group of compounds have a constant increment of change, like this series I explained, we have CH2 group, which is increment of change in the straight chain alkanes here. Look, like this, CH3, CH3, which is ethane. If you increase one CH2 here between them, it's propane, another or the next compound of hydrocarbon, alkane. If you have this propane and you increase one CH2 more, so now they are not one but two CH2 groups, so it's a butane. So ethane changes into propane, propane changes into butane, and so on. If you have like this series of compounds, we called it homologous series. IUPAC is the International Union of Pure and Applied Chemistry. In the case of alkane, they name them by the end of "ane" suffix. Suffix "ane" ended with any kind of compounds in alkane must be ended with "ane." Look at these examples and you'll see. First, if the carbon is only 1, 2, 3, or 4, this is 3 and 4, these 4 straight chain alkanes Carbon atoms here has the official name and the common name of are the same, which is methane, ethane, propane, and butane. But the names after that, C5 or C6, C7, C8, C9, C10, and so on, the chain is longer in each time. If it's 5, more than 4, I mean, if it's 5, we called it bent. So pentane and add ane at the end. 6 is hex. 7 is heptane. 8 is oct, so octane. 9 is nonane, and 10 is dic or decane. So we called it pentane, hexane, heptane, octane, nonane, and decane. In the case of alkane, we have a general rule, CnH2n plus 2, to find out number of hydrogens here. If you have number of carbon n, so the number of hydrogen must be 2n plus 2. Let's try. If you have, for example, butane, C4, if it's 4 here, hydrogen must be 2 times 4, 8 plus 2, 10. So C4H10 is butane. Let's try another example. For example, octane. Octane has 8 carbons. Yes. If you have 8 here, what number of hydrogen must be here? 2 times 8, 16 plus 2 equal 18. So C8H18 is octane, and so on. This is called general formula of alkane to identify how many hydrogen with carbon in the compound. This type of formula called not a structural formula as we said before, but molecular formula. But we are using structural formula more than this formula to represent the compounds that I drew before. Here we have some molecular formula for these alkanes, but if you want to represent each one by a structural formula, methane, CH4, you can do it like this. Ethane, C2H6, C2 here and H6 like this. 6 H's. Propane, C3H8 like this. This is C3H8, 1, 2, 3, 4, 5, 6, 7, and 8. And so on. We can try another one, like hexane, for example. C6H14, 1, 2, 3, 4, 5, 6. And look at hydrogen here, 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Make sure every time that you have 4 bonds around each carbon. 4 bonds every time. 4 covalent bonds every time. Don't forget that. Make sure it has like this. So if you want to draw the straight chain alkane, you can draw the carbons first as I did, then add the hydrogens and make sure you have single bonds every time and 4 bonds around each carbon. We are using, as I said, the structural formula I just show you, but we have different types of structure formula. We have something called complete structure formula, which shows all atoms and bonds, like this. Atoms here, all atoms, yes, are found here, and the bonds, all bonds here are found. If you show all of these bonds and atoms, it means you are making a complete structure formula. Sometimes we are using shorthand of this structure formula, but we cannot say complete, but condensed structure formula. How and what is meant by condensed structure formula? It means some, not all, some bonds or some atoms are left out. It means it doesn't appear all of them. How? Look at this. This is a condensed structure formula, and you can put the CH2 at the middle all together between parentheses, and you can put n number of them as subscript like this. Don't forget that the CH2 group that you are adding, it's a unit between the parentheses called methylene group. So if you have compound like CH3, CH2, CH2, CH3, for example, we have 2 groups or 2 units of methylene. You can write it by condensed structure formula like this: CH3, then CH2 by 2, then CH3, like this. You can do it like this. The subscript n is the number of methylene groups inside the parentheses. You don't need to show the bonds here between carbon and hydrogen. We have an example here. Look at this. It's exactly what I did. CH3 here, CH3 here, and CH2 by 2 at the middle. The CH2 group called the methylene unit, and this is a subscript as we said before. If you have this example C4H10, butane, we can write it by different methods. First, I told you it's a molecular formula, but you can show all atoms and all single bonds. At this moment, you are doing a complete structure formula. Okay. If you make the carbon-hydrogen bond only, not carbon-carbon, but carbon-hydrogen bonds, understood, so you can do it like this: CH3 all together here, CH2 here, CH2 here, and CH3 here. So you hide the carbon-hydrogen bonds. At this moment, we called it condensed structure formula with carbon-hydrogen bond understood. You can hide also this bond between carbon and carbon. At this moment, you can do it like this. At this time, you can say it's a condensed structure formula with carbon-hydrogen and the carbon-carbon bonds understood. You can, as I said, make the methylene groups all together between parentheses like this, and we can call this kind of formula condensed structure formula with all bonds understood. Also, you can call the carbon atoms linking together here only like this. And this moment you can say carbon skeleton, we called it carbon skeleton, with hydrogens and the carbon hydrogen bonds understood. It means carbon hydrogen bonds are understood, and also hydrogen understood. You don't need to draw hydrogen here or here like this. Also, we have a formula very important called line angle formula. You can write it like this, just show these bonds with all atoms, carbon and hydrogen atoms understood. It means if you have like this end or this start or this angle, it means carbon, and each one must have 4 bonds, one here, and this is 2, this 3, these 4 hydrogens. And this, it has 2 bonds here, it needs 2 hydrogen more to make other 2 bonds. Here it has 2 bonds, so we have to add 2 more bonds. This has 1 bond, we have to add 1 bond each around carbon to make them 4 bonds here. At this moment we can say the compound is a complete structure formula, but you can represent all of that by this method. Why? Because the bond between hydrogen and the carbon and the atoms, all atoms here understood. You can do it like this method called line angle formula. Let's try to do this problem. How can we draw the structure formula for alkane? We have 3 carbon atoms. If you have 3 carbon atoms in a straight chain, and if you have 4 carbon atoms. If you have 3 carbon atoms, first you have to make 3 carbons like this. Make sure each carbon has 4 bonds by adding hydrogen like this. 4, and this is 4, and this is 4 bonds, 4 bonds here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So this compound is 3 carbon atom compound. I did it by a complete structure formula as he needs. If you have 4 carbon atoms like this, draw the 4 carbons first, then add the hydrogen. Make sure you have 4 bonds around each carbon of them. That's it. And do it like this, and like this. Make sure each carbon has 4 bonds. This is the first type of arrangement of carbons, straight chain alkanes. The other type called branched chain alkanes. The branched chain alkanes, if you have carbon atoms which has 4 covalent bonds, yes, but the bond not only 1 or 2, but other carbons, also 3 or 4 other carbons, resulting in branched chain. What does it mean? It means if you have carbon like this, for example, and the compound has not only hydrogen here, hydrogen here, okay, but maybe it has another carbon here which has 3 hydrogen like this, and hydrogen here, and we can say carbon and the other carbon, CH2, CH3, like this. Then we can add hydrogen here. What happens here? All of carbons have 4 bonds, but not all of the 4 bonds linked with carbon here beside it or hydrogen, but Sometimes it linked with other carbon in a branches like this. So at this time we called it branched chain alkane, not straight chain. We have branches here and here. At this moment we can call these molecules, branching molecules, substituent. So what's meant by substituent? Are group of atoms that can take place of hydrogen atoms on a parent hydrocarbon molecules. Look, this is a parent alkane which has a straight chain, the main chain, like propane here, it has 3 carbons. But any branched carbons here not in the straight chain called substituent. Look at this, it's hexane, it has 6 carbons, so it's hexane. Hexane here, 6 carbons, and not straight. The straight chain is the parent alkane. This is the parent alkane, hexane. But it has 3 more carbons, yes, but they are branching. At this moment we call these groups of branching substituents. The longest continuous carbon chain called parent, but the branches groups called substituents, as I said. Also, if you have compound straight like this, but the branches are not carbon, maybe nitrogen, maybe oxygen, sometimes not in the hydrocarbon, I know, or if it's halogen like Cl, Br, and so on. At this moment we can call halogens like halogen or nitrogen or oxygen substituents as well. Substituents like this, C like this, butane, but butane is the parent alkane, but it has branches here like CH3 here, and maybe it has here CH2, CH3. If it's like this, CH2, CH3, or CH3 only, these branches are called alkyl groups. Alkyl groups are substituent derived from alkanes, but by removing one hydrogen atom. How come? It means if you have alkane like CH4, methane, by removing one hydrogen it becomes CH3. So this is alkyl group called methyl. If you have C2H6, which is ethane, the alkyl group is C2H5, or we can do it CH3, CH2, the same. 2 carbons, yes, and 5 hydrogens. We called it not ethane but ethyl. If you have C3H8, propane, it means the alkyl group is CH3, CH2, CH2, and the bond here, propyl. Propyl is 3 carbons, look, 1, 2, 3 carbons, with not 8 hydrogen but 7. 3 plus 2, 5 plus 2, 7. So you just remove one hydrogen from alkane, it makes a group called alkyl group, which is the branches in the compound. So alkyl groups are named by removing N and add YL at the end, and also you have in the formula remove one hydrogen from the compound. This is alkyl group. Look, The smallest three are methyl, I draw it, group CH3, ethyl group CH3CH2, and the propyl group CH3CH2 CH2. If you have substituent like this attached to straight a chain, at this moment we called it branches or branched chain alkane. This is the meaning of branched chain alkane. If you have parent alkane straight with branches here of one or more of alkyl groups. You know, the carbon at this moment can be attached with 3 hydrogens. Like this. Carbon with 3 hydrogen. And we have another carbon attached with 2 hydrogen only. Look, if the carbon attached with 3 hydrogens and only 1 carbon, it means it's a primary carbon. The types of carbon. If like this carbon attached with 2 carbons, not only 1 carbon, we called it secondary carbon. If the carbon attached to 3 carbons, it means, and here hydrogen, 3 carbons like this, like this, like this, tertiary carbon. If it attaches with 4 carbons, for the 4 bonds it has, so we called it quaternary carbon. So we have 4 types of carbon atoms in the chain: primary, secondary, tertiary, or quaternary carbons. Look at the example here. Look at this carbon attached with 3 hydrogen but only 1 carbon with the other, only 1 bond of carbon-carbon. At this moment, this carbon called the primary carbon. But look at this carbon here. This carbon attached with 2 carbons, one from here, one from this side, so we called it secondary carbon. If the carbon attached with 3 carbons, 1, 2, 3, and the 4th one is hydrogen, but 3 carbon bonds, carbon-carbon bonds, we called it tertiary carbon. If it attaches with 4 carbons, at this moment we called it quaternary carbon. They are the types of carbon in the compound. We have something called isooctane or iso. Octane means 8 carbons. Look, 1, 2, 3, 4, 5, 6, 7, 8. But what we can call it iso. What's meant by iso? Isooctane like this. Iso means hydrocarbon has or contains each of these types of carbon. Look at this example, for example. Look, it has this carbon, primary, linked with only 1 carbon. Yes. And it has secondary carbon like this. It has 2 bonds of carbon-carbon. And it has tertiary carbon, which like this, it has 3 carbon-carbon bonds. And also it has quaternary carbon like this. It has 4 carbon-carbon bonds. So it has, this compound has the types of carbons, all the types of carbons. If it's like this, we call these compounds iso. How can we name the compounds? We have some rules, IUPAC put rules. First, you have to name the, in the branch chain alkane, the name of the longest chain. You have chain of carbon like this, maybe branches like this, maybe like this. You have to find out the longest chain. This is a parent alkane. So first, you have to find out the longest continuous carbon-carbon, then identify substituents, or like this, group, branches, or like this. And you have to identify the number of and the position of this substituent. Look at this example and you will understand everything. This compound has long chain, look, carbon here, but the longest chain is 1, 2, 3, 4, 5, 6. This is the longest one, or 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. So the longest one 7, not this, but this is the longest one, 7. And this is a branch chain, or branches, these branches, these branches, these branches. Okay, we have 3 alkyl groups of branching groups. So we identify the longest chain and the branches as well. This is the first step to find out the name. So first, you have to find out the longest continuous chain, which is this. I told you. This is the first step. Then you have to find out the groups. Look at these groups. We can give them the name. This is methyl. This is methyl as well. And this is ethyl. Yes? And the parent chain 1, 2, 3, 4, 5, 6, 7. They are 7. So it's heptane. Yes? But to name the compound, you have to number them, number the heptane, and also identify the position of branches. So second step is number the carbons in the main chain. But look, you have to start from any side? No, not any side. But you have to start from the side that makes the branches lowest numbers. If you start from here, 1, 2, 3, 4, 5, 6, 7, the branches will take 4, 5, and 6. But if you start from this side, 1, 2, 3, 4, 5, 6, 7, the branches will take 2, 3, and 4, lower than the first case. So you have to cancel this and you have to start with this side, like this. 1, 2, 3, 4, 5, 6, 7. So it's heptane, as I said. And also we identify the position of the substituent. At 2, at 3 methyls, and at 4 ethyl. So we have at 2 methyl, at 3 methyl, and at 4 ethyl. What have to do afterward? You have to name the compound, but you have to use alphabetical order for the substituent. You cannot start with methyl because it starts with M, but you have to start with ethyl because it starts with E. But also we have 2 methyls, so it has 2 positions, 2 at 2 and at 3. At this moment you have to use the prefix di if they are 2, tri if they are 3, tetra if they are 4. At this moment they are 2 groups only. At 2 and at 3 they are di. 2 means di. So dimethyl groups here. Dimethyl at 2 and at 3. Then I told you you have to use alphabetical order, but the purposes of alphabetizing ignore the prefix di, tri, and tetra, and so on. It means if you want to use alphabetical order, yes, you will start with ethyl first, which is at 4. Don't start with methyl, but you can say, but methyl now has di, so D comes first. No, ignore the prefixes. You have to follow the alphabetical order with the main name of alkyl, not with the prefixes here. You understand? The next rule, you have to put the name without any spaces. And don't forget to make comma to separate numbers. If you have two numbers like 2 and 3, make comma like this. And make hyphens to separate numbers and word. It means if you are write 2, 3, die, you have to make dash or hyphen like this to separate between number and letters or words. 3 di methyl, for example. At this moment, we can write the name now. We are ready to write the name after all of these rules. First, we have heptane, but we have methyl here at 2 and at 3, and we have ethyl at 4, but we have to start with ethyl by alphabetical order. So, this compound is 4 hyphen because it's separate between letters and numbers. So 4 ethyl, then 2 and 3. I am writing right now number, so you have to make hyphen like this. 2 comma 3 because comma separates numbers from each other, then hyphen dimethyl, then the parent alkane, which is heptane, without any space. Look, heptane like this, without any space. At this moment, we follow all rules that we have to follow to name the compound. This is the method for naming compound. If you have like this compound, name this compound using IUPAC system. Notice the longest chain first. It's not a straight line, but you have to find out the longest chain. 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, 6, 6. Longest chain, longer than 5. But from which side we can start? If you start from this side, 1, 2, 3, 4, the branches here at 4. If you start from here, from this side, 1, 2, 3, the branches will be at 3. It makes them lower number. So you have to start from this side, 1, 2, 3, 4, 5, 6. Let's write the name here. We have at 3, the position 3, 2 methyls, alkyl group, substituent. So we have 3, comma 3, because both are at 3, and comma to separate numbers. Then hyphen, and di is the prefix must be here, dimethyl. Then the parent alkane, which is 6, means hexane without any space, hexane. So 3, 3 dimethyl hexane is the name of this compound. Look, as we did, and this is the name. With the name of branched alkane and by IUPAC rules, you have to reconstruct the structure if you have the name, and you need to draw the compound. First, you have to find out the root of the word. If it's heptane, octane, like this. Then draw the longest carbon chain to create the parent alkane. Then identify what substituents groups it has. Then add the hydrogen at the end. This is a method or 4 steps for drawing the structure formula. If you have the name, let's try this problem. You have here the name of a compound 2,2,4 trimethyl pentane. Sometimes we called it isooctane. Okay, if you have like this name and you need to draw the structure formula, first, as I said, from the steps you have to find the root, pentane. First, the root first, pentane. So pentane means 5, so you have to draw 5 long chain like this, pentane. Then identify the branches, substituent. You can start from any side because you are drawing the structure now. So start from this side or this side because you are doing the position of the branches here. Add 1, 2, 3, 4, 5, for example, here. Then add 2 and add 2 and add 4. Make tri means the 3 methyls. Add 2, make a methyl here. Add 2 again. Add 2, make a methyl here. And add 2, make another methyl here because it's 2 and 2. Add 4, make a third methyl here. Now we identify the positions of the substituents. The last one, adding hydrogen, make sure each carbon has 4 bonds. 1, 2, 3. This has 1, 2, 3. It needs only 1. Here has 1, 2. It needs 2 hydrogens here. This has 1, 2, 3, 4. And this has 1, 2, 3, 4. 4 bonds needed for this carbon. Now we finished to draw the hydrocarbon from its name. This is the method for this drawing formula, and this is the end of our lesson today. I hope to understand everything. Thank you, Shabab.